Okay, part 2 of lesson 4. Let's start out talking about how do the plates actually move. Now in class we would have done a demonstration about convection currents. And convection currents is something really easy for you to understand because you've learned about it probably in elementary school. When you were younger, or like when you did fire safety, they told you that the hot air did what? It rises to the surface. And so in a fire, you crawl along the floor because the air is cooler and it's hot at the top of the room. So heat rises. And you can feel that. If you stand near a fire, you can feel the heat coming up towards you. So all heat rises and cool things sink to the bottom. All right. That concept is what moves the plates. So let's look at that. The tectonic plates, we think, move because of the inner core, which is our hottest part of the planet, radiates that heat outward and it pushes the heat up towards the surface and it heats this magma layer that runs through the middle. And as the magma rises up to the surface, it's getting further and further from that heat source. And so as it gets up to the top, it cools and sinks back down to the bottom. But as it gets closer to the bottom, it's getting reheated and it circles back up. That is called a convection current. You see it in lots of things. The one that I think you can all visualize in your head is a lava lamp. A lava lamp works very similar to that. And I wish I had the ability to draw. This is one of those things I would draw on the board for you. But if you think about a lava lamp, the lamp is at the bottom, right? And the glass container sits on top. And the light bulb heats up that oil. And as the oil heats up, it rises to the surface and you get those little globs of colored oil that comes up to the top. And as it gets away from the lamp, it starts to cool down. And so it sinks back down to the bottom and it gets heated up again and it comes up. And so it kind of looks like your oil in that lava lamp is kind of moving in a loop, just like the loops that we think exist underneath the tectonic plates. Okay, so here's another picture that just shows that. As the magma rises up, and sometimes it escapes up here with a volcano, sometimes whenever it's moving, right, that up and down, it's pushing. See these arrows pushing to the left? And these are pushing to the right. So they are actually pulling those plates. They're pushing on them, just like a conveyor belt at the grocery store. When you put your items on it, that belt moves and it moves the objects on top of them. So as this force of this magma circulates, it's pushing the plate above it. So remember that the Earth is a 3D sphere. And so those convection currents are moving in all different directions underneath the Earth's tectonic plates. And so the plates are all being pushed and pulled in different directions. And in this example, they're showing you here that magma is creating a divergent boundary where the two plates are pulling apart from each other. Okay? Okay, I want to show you this little clip, and I don't normally do this where you can watch a video, but I just wanted to watch it. It's really quick. And this was something that I would show you in class. So take a look at a convection current animated for you.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. The remarkable cycle is complete.
Okay, so that was this picture in action. That was what this link was here. Okay, so in class we would have mapped the tectonic plates. And again, if I knew you had a printer, I would have you do this at home. But because I have no way of getting it to you, I'm just going to show you what it would have looked like. So I would have given you a world map, and you would have colored it. And then we would have labeled the plates. So here are some of the major tectonic plates on Earth. The green highlighted dashed lines are the plate boundaries, so that's where the cracks are. And then the arrows show you the direction that the plates are moving. Um, these are different boundaries, and we'll get to that later, so you can kind of disregard that for the moment, okay? But we sit on the North American plate. All of the United States, with the exception of a small sliver of California, sits on the North American plate. That little western part of California near San Francisco sits on the Pacific plate. Now, most of the Pacific plate, here's half of it here, and here's the other half of it, if you imagine the Earth being round. Most of the Pacific plate is ocean, but it is very, very tectonically active, and you have probably heard to that as the Ring of Fire. And we'll talk about the Ring of Fire a little bit later. There is a small plate up here near Seattle that has created the Juan de Fuca plate, and you can see my little volcanoes here and my mountain ranges. That's a pretty active plate as well that can cause some problems, and we can talk about that later. The Nazca plate is mostly ocean. The Cocos plate is down here near the Caribbean. You have the South American plate, the Antarctic plate, Australian plate, African, Indian plate. Remember, India had its own little movement, its own piece in our puzzle. The Arabian plate. The Eurasian plate is all of Europe and Asia. And then I think that's it. Did I get them all? I think so. We refer to as the plate boundary between North America and Eurasia as the mid-oceanic ridge or the mid-Atlantic ridge. So we'll talk about that a little bit and why that's so important. I've also noted the mountain ranges here where India ran into Eurasia. That pushed up the Himalayan mountains. So Mount Everest is over here, and we will talk about what happened in that area. Okay, so we would have taken about a day or two for you to color this map and label it and put arrows and look at it. Now you'll see this darkened line right here. We would have had you plot those points, and those dots that you can see that I drew with the marker, those are all places where earthquakes or volcanoes have happened. And as it turns out, when you connect those dots, those make up a plate boundary between South America and Africa. And there's a point to that, and we'll come back and look at it a little bit later. But for right now, these are the major tectonic plates on Earth. There are a few other smaller ones, but this is the main plates that you need to know. Okay, so what happens when plates move? So they have three choices. Plates can either move past one another, they can either pull apart from one another, or they can collide. And what I want you to do is I want you to read pages 39 to 44 in the book. And I know we've gone out of order, but I think you can go back and figure that out. Just find the pages in the link in the classwork feed. And I want you to read those pages and complete the data table that I provided. Now, we're going to do that two ways. I am going to provide you that data table, and if you have access to a printer, you can print it out and write in it and glue it into your notebook or tape it in. If that is something that's easier for you, you are able to print, you can do that. Otherwise, I will also create, I'll put a copy for each of you so that you can fill out your paper online if you would like to do it that way. But I know some of you hate switching back and forth between paper and digital. So you have two options: print and write, or fill it out online. Okay, and it's not graded, so it'll be listed as an assignment, just so that you have your own copy of it. But and I'm not going to put a due date on it because I don't want it to show up and you're missing work for you. But you really should do it. it's going to come in handy if you have it done. It can be kind of like a reference page. And then in the next video, we will actually go over the answers to that so that you'll be able to see what you should have written down. Okay? So when you get out of here, go ahead and read your book pages, complete your data table, and then check in with me tomorrow and we will review what you came up with. All right, guys. Thanks a lot.